Okay, so I'm now recording lecture 5. Um, so let's take a look at structured data and unstructured data. What is the difference between structured data and unstructured data? Structured data is something that has a strict format. For example, data that is stored in databases has a very strict format. That's structured data. Unstructured data or semi-structured data is somewhat ad hoc. So that is the difference between structured data and semi-structured data. In structured data, the type of data that is going to come in, the size of the data, everything is predefined. But in semi-structured data, it's not predefined. Let me give you a really coarse example for this. Let's say there's a box, and you just put stuff that can fit into the box, and whatever could fit into the box can be shipped. And then you have another box that is really, expandable, and you can change the size of the box depending on what you put in the box. All right, so this is kind of a example between structured data and semi-structured data, or sometimes known as unstructured data. So in the semi-structured data, the definition of the data is actually sitting right next to the data itself. Whereas in structured data, the definition of the data is defined by the schema. Since the data definition is sitting right next to it, it's called self-describing data. It's like if I'm walking around with a badge, and that badge has my name on it and my affiliation on it, then I'm describing myself, right? But if I have to be identified by using some kind of a display screen where my name and photograph is displayed, then you look at me and then you go back to the display screen and see who's this person, right? That would be another example for a structured data, where the data definition is not sitting right next to the data, but it's somewhere else. So semi-structured data could be implemented in a few ways. One of them is by using XML. Before creating the XML document, we have to understand the structure of the document that will be created. What kind of hierarchy or what type of information would be coming in has to be taken into consideration. So the primary object of an XML document is called the root, because we are talking about hierarchy. So it starts from the root and goes down to the nodes and to their children nodes. So this object the root object serves as a parent, and then you have the layers below. The uniform resource identifier is a string of characters which identifies a resource on the internet, whereas the uniform resource locator is a type of URI which is used to identify an internet domain address. So let's say there's a file on the internet somewhere. It's a text file, it's not an HTML file. A uniform resource identifier could be used to identify that particular text file, whereas a website could be identified using a URL. Okay, so XML has been pretty popular in implementing healthcare systems. A lot of interoperability standards and communication between EHR systems happens because of XML. So we go to the next topic here. So what is semantic web? Semantic means meaning. A semantic web is a web of data described that has where these data elements are semantically linked to one another. The semantic web address semantics through standardized connections. So there are standards for implementing semantic web. Here's an example for semantic web. Jane Doe is a chair for cool meeting. Where does Jane Doe live? She has a particular address, but that's not given here. So the question is, where does cool meeting happen? Cool meeting happens in Cambridge, Massachusetts. This is the latitude and this is the longitude of Cambridge, Massachusetts. Jane Doe has two identifiers. One is the email and the phone number. Cool Meetings has some privacy rules that is written on the website. Cool Meeting happens in Cambridge, Massachusetts, which has a postal code. So if you look at Jane's email and the postal code of Cambridge, Massachusetts, how are they related to one another? They're not directly related to one another, but you can see the linking and you can see how they're linked to one another. So this is how web semantic works. Here's another example for web semantics. All right. This is, in the current web, we have just linking resources, but in web semantics, we have semantics of the those resources that are linking. So that's the good thing about web semantics. So web semantics is a way to store knowledge somehow. It could be used for sales support, marketing, business development, decision support, etc., etc. Let's take a look at one of the ways where we could implement semantic web. This is a friend of a friend project where machine readable pages are developed using self-describing pages. You have XML documents. FOF is basically an XML document that defines how data elements within that XML document is linked to one another by using a friend of a friend approach. In a friend of a friend approach, if Alice is friend of Jane and John is friend of Alice, so this is how Jane is connected to John via Alice. So that's the idea in friend of a friend approach. So friend of a friend, just uses some basic machinery and all that. So you can take a look at this file. Harry is our guy. Harry Osborne is his full name. His friend's name is Peter Parker, and Peter Parker knows Aunt May. So this is how Harry Osborne is connected to Aunt May. And you can see the structure here that is used, that of XML, to show connection between Harry Osborne and Aunt May. Here's another example. Spider-Man is one, is the enemy of Green Goblin, right? Green Goblin is an enemy of Spider-Man, and Peter Parker is friend of Harry. So Peter Parker is the real name of Spider-Man, and he's a friend of Harry. This is how you display information using friend of a friend approach. Now we take a look at picture archiving and communication system. Picture archiving and communication system is an acronym. PAX is an acronym for Picture Archiving and Communication System. PAX is used for storing image data. For example, your MRI scans, CAT scans, CAT scans, so those type of things. X-rays, any image data can be stored using picture archiving and communication system. The reason why we use this standard for storing data is so that these images could be interchanged between different systems, and they could be comprehended or interpreted by different systems in the same way. So I've already spoken about this, so I'm going to skip this slide. So here are some of the major components of PACS. You got secured network for transmission, you got images, you got storage and archive of image studies and reports, and you got workstations used to retrieve, interpret, and review images. Again, you got radiology images from the Department of Oncology, and then you have images from surgery, you have images from pathology. They're all stored in a centralized server system. And if a clinician or someone else wants to access these images, they are accessed using the appropriate protocol. Here's the architecture where you have images stored in a different place, and then these images have to be accessed from different units that are located in different places. It could be a network of hospitals where you are seen by a particular physician in Chicago, and then you come down to Orlando and you are seen by a different physician, but the hospital belongs to the same network, so your images that are stored in Chicago are accessible to the hospital in Orlando because they are a part of the same hospital network. So that kind of dynamics is achieved using PACS. So 4 main uses of PACS is replace hard copy with medical images, easy access, right? That's the other thing. Create an electronic image integration system, provide radiology workflow management so that you can access these images from anywhere using a secure network. Of course, you have to keep in mind about HIPAA and making sure that you don't violate HIPAA. This is an example for a PACS server. I had a very interesting story to mention. Long time ago, when I was working for a hospital IT department, I was running the IT department, a physician asked me, how much storage do I need to store all the images that will be coming in every single day? I said, the number is infinite. Infinite means you don't know. Because, the images consume a lot of space, and you have to rapidly expand your storage device capacity to store these images. So sometimes people go for server farms where dynamically the storage space is expanded as new images come in. So it's a difficult thing to do. So these days we have electronic dental health record, again storing images of your tooth, x-rays on your tooth and all that, which tooth is good, which one is failed, which one got a root canal, etc. All those things are stored. So we move on to the next concept here, is insulation between programs and data abstraction. So these days, data and the computer program that works on that data are stored separately. So that you have program data independence and you have program operation independence. So what is a database? A database is a collection of related data. Data represents known facts that can be recorded and that have implicit meaning. So one of the definitions of a database is a database represents some aspect of the real world, sometimes called the mini world or the universe of discourse. This is one of the things that I may ask in the quizzes and midterm and final exams, so keep in mind, keep an eye on this definition. A database is a logically coherent collection of data with some inherent meaning. So the data that is stored in the database, they are all connected to one another. So for example, if you are storing information on the list of patients who are seen with the Department of Cardiology, there is an inherent meaning that these people were seen in cardiology, right? If they are seen in different hospitals across the country, it could be like a large database, but the meaning would be different in that particular case. maybe that database is handled by some organization like CDC or CMS or something like that. But in a database, the data stored has an implicit meaning. That is something that you need to know. Any information coming on from the universe of I'm not saying universe of discourse, from the universe is not getting into the database. So which is why we use the term the universe of discourse. We don't use the term universe, but we use the term universe of discourse, which means that the data that is stored in the database is actually belonging to a particular subject matter. Okay? Then we have a database management system. Some of the examples for database management system could be DB2, Oracle, your Microsoft Access is a database management system. So these are all examples for database management systems. The reason why we have database management systems is so that we can define data, we can construct data, we can manipulate data, and share databases. We can also define a database schema. We can identify the types and structures of data and the constraints of data that would go into the databases. So then what is metadata? Metadata is the descriptive information on the data stored in the database. For example, here's a database. What is the database about? It is about phone numbers. What phone numbers are we talking about? Phone numbers of people living in Oviedo, Florida. Okay. So that's metadata. Metadata is data about data. So some of the terms associated with database management systems are constructing a database, manipulating a data. Manipulating includes querying, updating, generating reports. For example, you want to know how many patients were seen by this particular department in this particular hospital. So you write a database query, and the database query would generate a report. Then you have updation of the database. For example, you want to include maybe a new column in the database for patients who are never seen before in this type of facility, something like that. Or maybe there's a new zip code in the area. I'm just making up some weird examples here. So these type of things. So or maybe there's a CMS requirement to capture some new type of data. That could be a new column, right? So then you have to update the database, add a new column. Sharing a database allows multiple users and programs to access the database simultaneously. An application program accesses the database by sending queries or requests for data to the DBMS. A query typically causes some data to be retrieved. So a query could be written by a human being or it could be written by a program. A program can dynamically generate a query depending on the situation, and that query can extract the relevant information. A transaction is some data to be read or some data that is written into the database. For example, you got a new patient. So then the person at the kiosk enters information on the new patient that goes into the patient database, right? Or it could be that a doctor wants to see what's wrong with this patient, so pulls up the patient's name by MRI number, social security number, one of those identifiers, and then looks at the history of that particular patient. So that's a transaction. Protection includes protecting the database from hardware and software malfunction, so you always have mirror images of the data. These days for patient data, they use extremely sophisticated systems, underground server farms for having mirror images of data. So that even if there's an earthquake or even if there's a natural calamity, the data is stored in servers in spaces where the natural calamity does not affect that particular place. Okay, maintaining database system involves its evolution requirements change over time. For example, there's a new statutory regulation. You got to change the database based on that. So self-describing nature of a database system is achieved by having metadata. So metadata kind of tells you what data is stored inside. Okay. All right. So thank you for listening. This is end of lecture 5.